Testing.
Good day, everybody. Welcome to Dr. Hugh Ross's Paradoxes Sunday School class. And happy to say Dr. Ross is back with us, safe and sound from his worldly trip. He's been in India and Hong Kong, so he's going to tell us a little about that. But today he's going to be speaking on our sun, amazingly and uniquely designed for advanced life. So we're looking forward to that. And just want to thank the people that brought all the treats today. And Dr. Ross will be back with us for at least through December, and most of January and February, but we'll see what happens. So with that, wow, someone brought in a big bouquet. Thank you. Let's bow our heads for one moment and welcome him up there. Lord God, we just thank you for this day and for your presence. And we ask for your blessing on Dr. Ross's message, that it be really uplifting for us and honoring to you. And help us, Lord, our minds and our hearts, that we can get into the lesson and use it as a good witnessing tool for you. In Jesus' name, amen. Come on up, Dr. Ross.
Well, it's great to be back here in the Paradoxes class. I think this is the longest in my entire, 47 years of teaching this class that I've been gone from the class. I've literally been gone for 4 Sundays. And I was introduced as having gone around the world. That's literally true. I missed my first Sunday. I was in Charlotte at the Steadfast Conference. That's an apologetics conference. And I was speaking on climate change, how to get past the political barriers of climate change. And then they had me speak on the latest scientific discoveries. I did some other speaking while I was there as well. Flew back home and then picked up a flight where I went to Dubai and then on to Hyderabad, India, and visited 3 different cities in southern India, then on to Singapore, then from Singapore to Hong Kong. Spent a week in Hong Kong, flew back here to Los Angeles area. I was here for a couple of days, then on to Washington, D.C., where I spoke at a conference there and some churches, and met with some of our constituents back there, and then flew back home. So I've literally been around the world ministering in different locales. And what I'm wearing is actually formal attire in India. They bought me one of these while I was in India. It's so hot and humid there, you don't want to wear a suit like they do in the U.S. They do that when they're in an air-conditioned building, but notice, no tie. This is considered formal attire, and got little pockets here. It's kind of nice. So that's one of the things I brought back with me from India. And I can tell you we have an amazing team. Reasons to Believe, 2.5 years ago, launched Reasons to Believe Asia Pacific, and I can't tell you how I'm impressed with the scientists there and the other economists and people working with them, videographers. I mean, they just have an amazing team. All of them really manifest Christian character to a degree that was really impressive. So I was just overjoyed just seeing the ministry impact they've been having and just the opportunities to partner with them. In Hong Kong, and by the way, what's interesting about India is that when you share your faith, you have to avoid talking about the benefits of the Christian faith. That's considered to be bribery, and you can be prosecuted for that. And so we talk about how becoming a Christian is a cost. It literally costs you everything. And that worked out quite well. In Hong Kong, we had a really, I mean, this is my third time to Hong Kong, but my previous two trips were, about 30 years ago, and then just before the British were handing over authority over Hong Kong to China. And what happened, we had a really thriving chapter there, but it was headed up by expatriate professors at the leading universities in Hong Kong. There's some really outstanding universities, and particularly the Hong Kong Institute of Science and Technology. We had several scientists who were professors there who were heading up our chapter. But when things got transferred from the British to the Chinese, these expatriate scholars all had to leave, and it collapsed our chapter. So one of the reasons why I was in Hong Kong was to restart the Hong Kong chapter. But what I can tell you is impressive is we got to meet with a lot of scientists who are Christians and really bold about sharing their faith with their peers as well as with other people. And some of them rank as the top scholars in the world in their discipline. And they've got the same strategy and plan, which is to use Hong Kong as a base to reach out to people throughout China, and especially reaching out to the educated people throughout China. And I think it's going to be more effective because now it's based on indigenous Chinese scholars rather than American and British scientists who went there, quote, as missionaries. So that was really quite exciting to see. And then making a trip to Washington, D.C. And one thing I can share with you is that at Reasons to Believe, we have found 15, maybe as much as 20 medical researchers who are working with us basically to expose the problem of transgenderism. I mean, it's a new phenomena where you've got men wanting to be women and women wanting to be men, and how they seek medical help to transition from one sex to the other. Well, we've assembled a team of Christian medical researchers who've basically been looking at their own research and diving into the scientific literature and documenting that this is a violation of the Hippocratic Oath. I mean, every medical doctor takes an oath before they're allowed to serve not to harm their patients. And there's now overwhelming evidence that this transition from male to female or female to male has devastating not only psychological consequences, but physical consequences. In particular, in both cases, it damages the liver, the cancer rate goes up, heart disease goes up, diabetes goes up. There's just a huge number of health consequences that come from this. And our hope is we're actually getting this team together to produce a small book, a white paper, and it's designed to persuade the medical community, Christians and non-Christians alike, that this is harmful to the patients that they're treating, and for simply the physical reasons. Forget about the mental reasons. The physical reasons alone are sufficient to ban any attempt to transition from being a physical male to a physical female or vice versa. I mean, and it'll be a while before we know the full extent of these consequences, but the medical researchers I've been talking to, they say, we're thinking at a minimum it takes about 10 years off your lifespan. And even though people have been transgender for only a couple of years, you can see significant health consequences to the decision that they've made. And when I was in Washington, D.C., I was speaking in a church at a conference, Digging Deeper it's called, and they really like Reasons to Believe. They had me speak 3 times at their conference. But one of the messages was given by the senior pastor, who's just gotten a doctoral degree on the transgender issue, and he had no idea that we had this team. And I said, would you like to be part of the team? He says, I'd love to be part of the team. He says, I'm a theologian trying to get a handle on this. It'd be really good to engage these medical researchers. And yeah, the team involves both theologians and medical researchers and gynecologists, and is headed up by a gynecologist That's part of our Reasons to Believe Scholar community. That's the other thing I've found exciting, is just being in India and China and Washington, D.C., and being able to recruit literally several dozen more scholars into our scholar community. As you've probably heard, we have a long-term vision to build up a scholar community of 1,000 doctoral level scholars who work with us to reach our peers for Christ and also to develop new apologetic tools to reach the masses for Christ. And our goal was to be at 200 before the end of this calendar year. It looks like we're going to be well above 225, maybe even close to 250. We got several that are in the queue, so it's looking really good in that respect. But what I appreciated about the senior pastor of this Burke Church I was speaking at is he said, we need to come up with a good analogy for what's wrong with this transgender phenomena. And the analogy he came up with was, what about anorexia? People who think that they're too fat, and they begin to go to extreme measures to make themselves look thin. Now he says if we were to follow the transgender model, we would go to these people that are basically starving themselves to death and say, let's do surgery on you to make you thinner. We don't do that. When we run into someone who's suffering from anorexia, we treat the mind. We don't try to transform their body. Likewise, what our community is saying is the way to deal with these people who are wanting to change their sex, we treat their mind. We don't cave in to their wishes to transform their body. And so, you would be prosecuted if you took, say, an anorexic woman and basically did surgery on her to take more weight off of her body. You'd be violating your Hippocratic oath. Well, in the same way, it's a violation of the Hippocratic oath. So I've been really blessed with these past 4 weeks, but I'm glad to be back here with the group. And incidentally, I see a real opportunity in Asia for the expansion of the Christian gospel. When I got back from Washington, D.C., while I was on my travels, I did do some writing while I was on airplanes. I spent a lot of time on airplanes and in waiting rooms at airports, so I took advantage of that time to write. And one of the articles I wrote was how, when you look at Genesis 10 and 11, it speaks about how humanity, after the flood, was rebelling against God's command. Instead of multiplying and filling the earth, they stayed in one place. And God basically came down and scattered humanity over the face of the earth. And I did some research in the scientific literature, and in the last year, there have been studies showing that the date for the migration of humans out of the Middle and Near East into Northern Europe and Southern Europe, you get a date of that happening about 42 to 47,000 years ago. The date you get for people going into Southeast Asia, into the Philippines and Borneo, also is 42 to 47,000 years ago. The date for people going into New Guinea, Australia, and Tasmania is 42 to 47,000 years ago. The dates are all the same, basically making the point, indeed, there was some event that caused humanity to aggressively migrate out of the near Middle East and Eastern Africa into all parts of the old world. Now, it didn't happen in North and South America because the Bering Land Bridge was impassable. But there came a time, around 15,000 years ago, where people began to migrate from Asia into North and South America. Well, what I did is I wrote an article basically documenting this. Then I took a small piece of that and basically showed a map. Because one of the challenges is, how do you get people 42 to 47,000 years ago migrating from the near Middle East into Borneo and the Philippines and Taiwan and into Australia, Tasmania, and New Guinea? Because there's huge expanses of ocean that prevent that. But during the last ice age, and the last ice age is 15,000 to 130,000 years ago, So 42 to 47,000 years ago, you're in the middle of the last ice age, where sea levels were 390 feet, 120 meters below the present sea level. And with sea levels that low, you've got a continuous landmass joining Southeast Asia to Borneo, Indonesia, the Philippines. People could walk from the Middle East right into the Philippines and Borneo. And yes, there was open ocean water separating Indonesia from Australia, but it's such that you could see land on the other side and cross over, whereas today that's not the case. And it's also a time when Tasmania, New Guinea, and Australia were all one continent. They were all joined together because of lower sea levels. Well, I posted that map on my Facebook page. Now, before I did this, I had 29,000 followers on my Facebook page. And when I put this post up, well, it's still going up, but right now it's getting close to 34,000 followers. Usually it takes me about a month to add 300 followers. This time it was happening literally within just a single day. And a typical post I put up, I might get 10,000 people looking at it. In this case, 7.7 million people were looking at it. And then I did a study because I wound up getting 4,600 questions and comments. I haven't been able to answer all the questions. When you want to volunteer and help me answer 4,600 questions, I'll take you up on it. I did answer a couple of hundred of the questions, but it led me to discover those 7.7, and it's going up, it's still going up, million people that were responding to this post. Almost all of them lived in the Philippines, Taiwan, Malaysia, Vietnam, Australia, New Guinea, Indonesia, a lot of Indonesians. And in every case, they had heard of young earth creationism. They had heard of theistic evolution. They had never heard of the reasons to believe day-age model. Atheists jumped in saying Christianity is nonsense, but when they began to discover, hey, this is different. But what it showed me is, even though we've been around for 37 years, a lot of people have not heard of Reasons to Believe. Even though Reasons to Believe Asia Pacific has been up and running for more than 2 years, still the vast majority of Asians have never heard of Reasons to Believe. They've heard of everything else, but not Reasons to Believe. But the response was truly very encouraging. And so we see a huge opportunity for ministry in that part of the country. So anyway, let me dive into what I wanted to talk about today, which is our sun. And, Neil deGrasse Tyson, he's an atheist, he's an astrophysicist. He's probably the best known astrophysicist, at least in the United States, if not the world. He is the successor to Carl Sagan. I knew Carl Sagan when I was at the University of Toronto. He taught a week-long course to us there. And when he passed away, Carl Sagan's wife looked for someone to take Carl's place. That's Neil deGrasse Tyson. But he was caught in an outtake once when they were preparing him for an interview. And what he said in the outtake was, the universe is a dangerous place. At every opportunity, it's trying to kill us. Well, there's some truth to what he says. Once we get beyond planet Earth, everywhere we look in the universe, we see conditions that are hostile to advanced life. The universe really is out to get us. At every opportunity, it's trying to kill us. And we make a mess of planet Earth, we're in deep trouble because there's nowhere else to go. Everywhere else, we're looking at very deadly conditions. Now, probably the best example of that is our star, the sun. We really can't find another star that's like our sun. So I'm just going to talk to you about our amazing sun. And hey, we're coming up to Thanksgiving, right? Hopefully after you hear what I got to say here, one of the things you'll say in your prayer over your Thanksgiving dinner is thank God for our sun. Without our sun, there'd be no turkey on the table. Without our sun, there wouldn't be any people around the table. Without our sun, there wouldn't even be a table. Okay. Now, as I mentioned before, I've written 7 whole books on how the universe and everything in it is designed to make possible the redemption of billions of human beings. And our series in going through this, we've been looking at how our universe is fine-tuned to make our existence possible. Not just our existence, but our redemption. That's true of our super galaxy cluster. And there is no super galaxy cluster like the one we're living in. It is unique in its capacity to enable advanced life to exist within it. We also live in a unique galaxy cluster, a unique galaxy group, and I just spent a couple of weeks with you talking about how we really need to thank God for our Milky Way galaxy. If you go to reasons.org/fine-tuning, you'll see there that I give you 200 different design features of our galaxy that make our existence possible within our galaxy. And there literally is no other galaxy we see anywhere in the universe that has the characteristics that make advanced life possible. Well, now we're going to look at our star. Now, one of the big breakthroughs in revealing to astrophysicists that we happen to orbit a really special star, a star like no other, is this mountain in Italy. Okay, this is Mount Gran Sasso, and it's a mountain of limestone. It's part of the I forget how to pronounce it, the Apennines. So it's the tallest mountain in the Apennines that runs down the spine of Italy. And it's a limestone mountain. And when physicists saw this, they said, wow, this gives us a special opportunity. We can actually dig a tunnel under this mountain and be able to put laboratories there where we can look at what's coming out from the universe and our sun, where we're going to be able not to be contaminated by cosmic rays. Because with thousands of feet of limestone above the laboratory, that will take out the signal from the cosmic rays. And the problem with doing solar astrophysics is getting rid of the cosmic ray noise. There's so much noise from the cosmic rays, you really can't tell what's going on with the sun. And so they use this Italian mountain as a way to filter out all that noise that's coming from cosmic rays. And so they literally dug a tunnel underneath it. In fact, this next one here shows you the above ground scientific laboratory there. And there's a tunnel that goes from the lab that goes right underneath that mountain. And then they have these huge caverns underneath this mountain where they do physics experiments. And so 4,600 feet of sedimentary and limestone rock exists above the physics laboratories. And what they have in one of these physics laboratories is a neutrino detector. And so what they're trying to do is measure neutrinos coming out from the sun. And the interesting thing about neutrinos is it tells you what's happening in the sun right now. You don't get that from the photons. The light that we see coming out of the sun originally comes from the nuclear furnace inside the core of the sun, but those photons, they wind up getting beaten around as they try to get out from the nuclear furnace to the surface. Even though these photons are traveling at the velocity of light, because they're being bounced around inside the sun, it takes 100,000 years for a photon produced by the nuclear fusion furnace at the core of the sun to get to the surface of the sun. So when we look at the light coming out of the sun, it tells us the condition of the nuclear furnace of the sun as it was 100,000 years ago. Now, the advantage in the neutrinos is they don't get bounced around by the atoms inside. Matter of fact, if you look at your thumbnail, about 10 trillion neutrinos go through your thumbnail every second. And probably you don't even notice it, right? Oh, gee, those neutrinos are causing me problems. No, because neutrinos do not engage the protons, the neutrons, and the electrons, literally quadrillions of them go through your body every second, and they don't disturb anything. Well, the same thing is true of the neutrinos produced by the furnace in the core of the sun. They do not engage the protons and neutrons and electrons, so they literally travel from the core of the sun to the surface of the sun at the velocity of light. So they get out in a fraction of a second, and then they come on, and we can detect them with this detector. And that means we now know the condition of the furnace inside the sun as it was 8.5 minutes ago, because that's how fast the neutrinos travel from the nuclear furnace to this neutrino detector we see under this Italian mountain. And so this is in fact, I think there's a man on this. Yes, you can actually see a man climbing a ladder. So it gives you an idea how big this detector is. And so they have this huge detector filled with liquid xenon, and then they got 4,600 feet of sedimentary rock above it. This is all designed to ensure that there's no cosmic ray noise. And the xenon is designed so they can pick up the few neutrinos. Now, neutrinos do engage photons, but they engage it at an extremely weak level. And so they're basically using this liquid xenon, and they surround it by thousands of photometers, which is designed to pick up the stray neutrino that happens to engage a photon. And you say, well, how many detections do they get? Well, they're looking at getting a few neutrino detections per week, a handful per week. But if they continue to observe week after week after week, they collect enough neutrino events, it tells them what's happening in the core of the sun. And what it is revealing is that the sun is in a key transition. I think I put it, this is in the book Design to the Core. I also wrote an article on it. You can see it at reasons.org under my blog series, Today's New Reason to Believe, is that they discovered that there was one kind of neutrino coming out that is a signature of what you get when hydrogen is fused into helium. The sun is often described as a gigantic hydrogen bomb. It's fusing hydrogen to helium. That's where we get the heat and life in the sun. But there's another neutrino signature that they're seeing that tells us that some of the energy flow from the nuclear furnace is from the fusion of helium atoms, helium nuclei, to make carbon, oxygen, and nitrogen. Now, it took years of observations with this neutrino detector under Mount Grosso in Italy to determine, yes, about 99.3% of the energy comes from fusing hydrogen to helium, but about 0.5 to 0.7% comes from the fusing of helium nuclei to make carbon, oxygen, and nitrogen. And because they can see the light coming out, which tells them what was going on 100,000 years ago, and the neutrinos coming out, which tells them what was going on in the core of the sun 8 minutes ago, they can see that the sun has gone through a transition where it's gone from getting all of its energy from fusing hydrogen to helium, where now it's beginning to ignite what's called the C&O cycle, where you get 3 helium nuclei fusing together to make a carbon nuclei, then a nitrogen and an oxygen nuclei. And what this is telling them is that there's a transition going on in the core of the sun. So this is what the interior of the sun looks like, where you got the nuclear furnace, the core. Then you got what's called a radiative zone, where energy simply radiates outward. Then you got an outer layer, which is a convection zone, where you got a lot of turbulence going on and mixing going on. And then there's a very thin radiative layer, the photosphere, that surrounds the convection zone. But that tackle line there that you see is the line, it's basically a very thin layer that separates the convection zone from the radiative zone. And this transition that's taking place, what it does is that it changes the physics of what's going on at the tackle line so that we now have very little flaring activity from the sun. And so we're in this unique time window, literally just 100,000 years wide, where the sun has extremely low flaring activity. Now, flares aren't going to kill you unless they're really, really bad, but our sun is of such a mass that it doesn't generate flares that wipe out all of humanity. They might increase your cancer rate, but what these flares do, however, they pose a problem for civilization. So the most recent event of that, to quote, problem is a solar flare that occurred in 1859. It's called the Carrington event, named after the astronomer that devoted considerable study to it. And not all flares aim towards the Earth. So, for example, if you want, how many of you have ever seen the aurora borealis? Okay, a few of you have. I grew up in Canada, so I saw it quite frequently. In fact, I saw it where it was an annoyance for astronomy, where the aurora would be so spectacular, we'd have to shut down our telescope because we weren't able to look at stars and galaxies. The aurora literally filled the entire night sky, all different colors, moving all night long. It was like a laser show. But I remember my fellow astronomers cursing the aurora because it prevented them from doing their astronomical observations. Now, if you want to see the aurora, the NASA website now gives you warning, because when you see a major solar flare that's aimed at planet Earth, you know that within about 24 to 48 hours after NASA announces the flare, there's going to be a spectacular aurora display on Earth. So that's the time for you to buy a ticket to Iceland or to Greenland or to go up into northern parts of Canada. In fact, there's now a tourist industry where they fly people to Churchland. That's on the northern part of Hudson's Bay. They got some nice hotels there. And while you're there, you can see polar bears. You can swim with beluga whales. They put a dry suit on you. The beluga whales love humans, so it's kind of a neat experience. But thanks to NASA, you get about 24 to 48 hours notice. You book a flight to Churchland, and you get to see the aurora. Okay, 1859, there was an aurora that was so intense that people literally got up early and thought it was dawn. It was so bright they thought the sun was up already in the middle of the night. So people were getting up thinking, hey, it's time to make breakfast and get everybody up and running. But where it affected our civilization is it shut down most of the world's telegraph systems. In fact, there were telegraph operators that got electrocuted as a result of the aurora affecting the telegraph system. But hey, by the next day it was all over. It was relatively straightforward to repair the telegraph system. Everything was up and running, and it really didn't do much impact on global civilization, except for those few telegraph operators that needed some treatment. Okay, but fast forward to 2023. What would happen today if we had a flare like we had in 1859? Well, we actually had one in 1989. It was about 1/10 the strength of the flare in 1859. And probably you don't notice, but I remember back in 1989, I saw the aurora here in the Los Angeles basin. Now, it wasn't anything like I saw in Canada. It was basically just a big red blob up in the sky that didn't move and didn't change color. And I said, well, that's pretty dumb. I mean, I've seen things way more spectacular than that. But hey, Los Angeles, look how close we are to the equator. And yet there was this big red thing up there in the sky from the 1989 solar flare. However, it shut down the Quebec power grid. And that was bad news not just for Quebec, it was bad news for Boston and New York, because they got a lot of their electricity from the Quebec power grid. And the Quebec power grid is fed by these huge waterfalls that you see in northern Quebec and Labrador. And so a lot of the electricity of the American Northwest comes from there. Well, it was shut down, and the damage from that shutdown was $11 billion. So, that's an economic hit, particularly for the province of Quebec. And so, but no other power grid was affected. You say, how come the Quebec power grid was knocked out and no other power grid? Well, the Quebec power grid happened to be closest to the North Magnetic Pole, so it got the biggest hit. So Now, the Quebec government said, hey, this could happen again. And so they spent $1 billion to surge protect the Quebec power grid. Today, the Quebec power grid is the only protected power grid in the world. If we were to get another flare like we had in 1859, it's going to shut down power grids all over the world. Okay, go back to 1859. How many people had electricity coming to their homes? Almost nobody. Okay, I mean, you had Edison playing around with it in a building or two, but that was it. Nobody had electricity. But today, everybody's got electricity. And moreover, we have a large population of people that live in the American South. Have you noticed there's been a big migration of people from the American North to the American South? Notice that didn't happen until electricity was pumped into all the homes and buildings in Atlanta and Houston and Miami, which meant people could have air conditioning. And so the reason why the economy is thriving in the southern states, especially the southeast, is they've got air conditioning. Yeah, it gets really hot and humid when you go to Houston, say in July. It's unbearable going outside. I've been to Houston in July. You got to change your shirt about 5 times a day. You got to shower 3 or 4 times a day. That's how miserable it is. Then you go to an air-conditioned building, and the air conditioned to about 60 degrees Fahrenheit. You freeze, so you put on a jacket, and you go outside. And what I noticed when I was in India, it's a place that's very hot and humid, especially southern India where we were. But it was amazing how ubiquitous air conditioning was. Okay, we get a flare like we have in 1859, suddenly no air conditioning because the power grids are all knocked out. Okay? And people are really going to suffer. In fact, because we're so used to air conditioning, we're not adapted like people were in the 1850s, where they were basically saying, okay, when that happens, we all go down the river and we just soak ourselves in the river. Well, the population's much larger today, so it's really not practical for that to happen. Moreover, people haven't got kind of a plan worked out what to do when it gets that hot and humid. They just turn on their air conditioner. And so we have the potential, literally, of millions of people dying if the power grids of the world get knocked out. Moreover, it knocks out your refrigeration systems. And how many of us are dependent on refrigerators to maintain our diet? What happens? I mean, probably a few of us have had power outages where your refrigerator no longer had power. Well, the power outage only lasts for a day. You can probably keep most of your food, but what if it lasts for a month? What if it lasts for several months? And suddenly you've got a food crisis, a worldwide food crisis. And I remember sharing this with my sons and saying, well, it would also knock out almost all the GPS satellites. And they said, for that reason alone, Dad, that would be the end of civilization as we know it. Because young people especially are really dependent on those GPS satellites. And so knock out all those GPS satellites. Where are all the Thomas Brothers maps? How many of you remember Thomas Brothers maps? Okay. Everyone here is over the age of 40 remembers Thomas Brothers maps, where you had a stack this high of Thomas Brothers maps in your car, and whenever you needed to go somewhere in the LA Basin, you had to open up one of these maps and figure out where to go. Everybody's thrown away their Thomas Brothers maps because now we got GPS satellites. So, but hey, if the GPS satellites are gone, how many of you kept your Thomas Brothers maps? We threw ours away. Oh, you still got yours? Okay, if we get a solar flare, I'm going over to your place and borrow your Thomas Brothers maps. But most people have thrown them away. So, and by the way, they've updated all the streets, so it's like, even if you kept your supply of Thomas Brothers maps, it's not going to be up to date. And you're going to have problems getting around the LA Basin. And here's a problem. There's papers published basically making the point worldwide, people under the age of 35 have got a shrunken hippocampus. The way the human body works, if you don't use it, it throws it away. This is the problem when we send people up into the space station, is that if they get used to zero gravity, their body says, we don't need all this bone mass in our skeleton anymore. And so the body basically sheds the bone mass. I mean, this is true of all life. But I remember my son was raising peppers inside of our home, and quickly realized that the peppers were basically just these tall, thin, spindly things. You blow on them and they fall over. And so one of his friends said, you have to blow fans. You need to buy a fan and to blow on your peppers, because otherwise the pepper plant says, hey, there's no wind here. I don't need to build a strong stalk. And then when you get the peppers simply fall off. There's not enough strength in the pepper plant to maintain. So if you want to get good, healthy peppers, and you're going to raise them inside your home, get a fan and simulate what happens outside when you've got wind, because all life forms will shed what they don't need. Well, with GPS satellites, we don't need, the hippocampus is that part of your brain that does navigation. But if you don't need to do any navigation, if you got a smartphone that does it all for you, that part of the brain doesn't get exercise, and so it begins to shrink. And that's where these people under 35 need to maintain relationships with those of us that are in our 50s, 60s, and 70s, because our hippocampus is still big enough that we can actually get an old Thomas Guide map and figure out where to go. So, bottom line is that, what this I wrote about in my book, Weathering Climate Change, it would be a wise investment for all the governments of the world to protect the power grids. Do the same thing that Quebec did. Now, it's going to cost tens of billions of dollars. But we know flares like what happened in 1859 are going to happen about every century, once a century. It's been 150 years, 170 years since we had a flare of that size. It's inevitable that one will happen. And when it happens, without the power grids being protected, you're looking at tens of trillions of dollars of damage. And you're looking at millions, tens of millions of people dying. And so it'd be worth our while to spend a few tens of billions of dollars to protect the world's power grids. It's just a good insurance policy to put into effect to do that. Okay, I got a bit diverted from what I was trying to talk about with the sun. But that's actually part of it. Yeah, kind of that is. You know, we think about the dangers of these solar flares, but we need to appreciate we're orbiting a star that has the least flaring activity of any star we know. If we were orbiting any other star, these kinds of flares would be happening at 10 times the level of the 1859 flare, and at 10 times the level, that means we begin to have millions of people dying from the direct exposure of the flare radiation. And so we are orbiting a star that has so little flaring activity, we can actually sustain global civilization. And we spend some money protecting our power grids, we can have a flare like in 1859, nobody dies, and it doesn't collapse the world economy system. Doesn't do any damage to our food supply. But that's all because the sun is going through this unique transition. Old stars fuse by the carbon, nitrogen, oxygen cycle. Young stars by the hydrogen to helium cycle. And our star is at that point of transition where it's going from 100% of its energy coming from the fusion of hydrogen to helium, where now we got about 0.5% to 7% coming from the C&O cycle. And research on this has established this is what's responsible for the sun having such a tiny level of flaring activity and so little particle radiation that runs the risk of destroying our ozone shield. Now, I won't go into the complexities of all of this, but the reason why we have so little flaring activity not only is because of the design of that layer that separates the radiative layer of the sun from the convection layer, this layer here, but also because the interior of the sun has what we call differential rotation. Here we go. So what we notice is that when you get down, this tells you, okay, basically when you're going down at the fraction of the sun's radius, as you go down towards the surface of the sun out to about 4/10. Okay, here we are. You notice when you look at the surface of the sun at 26-day rotation period. Sun rotates once every 26 days. So if you're looking at sunspots on the sun, you'll notice those sunspots slowly move as you observe it day after day after day. By the way, this is now a really good time to see sunspots. If you've got a good pair of binoculars, you can see sunspots. Make sure you shield your eyes, however. Or what I do, take the pair of binoculars and simply project the image of the sun on a piece of cardboard. You project it to about a 1-foot diameter sun, you can clearly see the sunspots, and you don't need to protect your eyes. Just basically use your pair of binoculars to focus the image of the sun onto a sheet of paper. And by the way, we're going to do that for the solar eclipse coming up in April. We're going to take telescopes out there in Texas, and we're going to be projecting the image of the sun on giant pieces of cardboard. Where literally 100 people at one time can see the moon's image going over the sun, and you can watch the sunspots disappear as the moon moves across it. But what you see here is that you do have differential rotation. Some layers of the sun, the rotation rate is 23.8 days. Other parts, almost 30 days. The surface, everything's at 26 days. But this also is a factor in why we have such little flaring activity. Okay, next image. This is showing you the luminosity of the sun. Next slide, I'm going to show you the flaring activity of the sun. But what this reveals is that when the sun is forming, it's accumulating mass. And so the sun began with less mass than it has today, but it actually built up a lot more mass. So the sun at one time was much more massive than it is today. Got to be about 50% more massive than it is today. That affects the brightness of the star. A star's brightness goes up with a 4th power of its mass. So that means you double the mass of the star is 16 times brighter. So that explains why high mass stars are so bright in the sky compared to low mass stars. Am I messing with the camera there? I'm sorry. I'll try to stay in one place. Now, keep in mind there's a lot more people watching this than people we have here in person. Okay, so when the sun's forming, it's getting very bright and getting very bright quite quickly. Then it stops accumulating mass, and then it begins to lose mass. And when it loses mass, it gets dimmer. And then it ignites the hydrogen bomb nuclear furnace. So in the core of the sun, a hydrogen bomb gets ignited, and the sun begins to fuse hydrogen to helium. But notice that helium has a higher density than hydrogen. And so as the density at the core of the sun gets greater and greater because of the conversion of hydrogen to helium, that greater density causes the nuclear bomb process to become more efficient. And so the amount of energy being produced from the fusion of hydrogen to helium in the core of the sun gets progressively more and more efficient, which explains why in the history of life we see that the sun has gotten progressively brighter with respect to time. Now, the sun today is about 23% brighter than it was when God created the first microbes on the face of the earth. And I think I've shared this with a class before. Whenever I engage atheist evolutionary biologists, I always say, well, you're an expert on genetics, you're an expert on paleontology, but have you ever factored solar astrophysics into your understanding the history of life on planet Earth? The vast majority of them basically say no. We haven't done that. But it plays a crucial role because it means you've got to have different life on planet Earth at different times. Life can only tolerate about a 1% change in the brightness of the sun. And what you see in Psalm 104, it's a property of all life to die off, but God recreates and renews the face of the earth. Psalm 104, verses 29 and 30. And so as the sun gets progressively brighter and brighter, God removes life from planet Earth and replaces it with new life, where that new life is more efficient in drawing greenhouse gases out of the atmosphere of the Earth. If it wasn't for the greenhouse gases in the atmosphere of the Earth, the surface of planet Earth would be a little bit more than 30 degrees centigrade warmer than it is right now. At that temperature, all animal life, all plant life would die. We can't handle that degree of heat. If you want to convert that to Fahrenheit, let's see, that would be 32, we're looking at about 55 degrees warmer. So take the temperature of today, add 55 degrees to it, it'd be a bit unpleasant. And, on a hot day, I mean, everything literally would die. But God basically is removing life from planet Earth and replacing with life that draws down the efficiency of our atmosphere to trap heat from the sun. And so because of God, and this is something you can thank God for when you have your Thanksgiving dinner, what God has been doing is removing life from planet Earth, recreating life, but recreating life so that it perfectly compensates for the brightening of the sun. He's done that continuously for 3.825 billion years. That should give you a good reason to thank God for what he has done when you celebrate Thanksgiving these next few days from now. By the way, what nation of the world, trivia question, was the first to launch Thanksgiving as a day to thank God for his provision? It's Canada, not the United States. U.S. was second. Canada did it about 20 years before the U.S. did. Maybe because they got more turkeys up there, I don't know. So, and, as a dual citizen, I get to celebrate Thanksgiving twice. Because in Canada, because the harvest is so much earlier than it is here in the U.S., they celebrate Thanksgiving the second Monday of October. We celebrate it the fourth Thursday of November. Because, being farther south, you can get the food an earlier or later time of the year. But hey, we get to celebrate Thanksgiving twice. But we should be thanking God every day, right? Okay. Anyway, back to what's happening underneath that mountain in Italy. Okay. This shows the flaring activity of the sun. And the flaring activity throughout the sun's history is also proportional to the amount of X-ray radiation it's pouring out, short wavelength ultraviolet radiation. Those are the killer solar radiation coming out from the sun, and also correlates with the particle radiation that works to sputter away our atmosphere. And this scale is logarithmic, so where you see at beginning, at the top there, that's a level about 100,000 times greater than what is today. But that dotted line you see there, the black dotted line, basically shows you where we are right now. Basically making the point, God created us human beings at the moment when the flaring activity, the X-ray radiation, the short wavelength radiation, all this stuff that causes cancer, for example, is at the extreme minimum for the sun. It's literally 100,000 times less than it was when the sun had newly formed. And then that green dotted line basically shows you where the particle radiation, the flaring activity, the X-ray radiation reaches a level where you can now have microbes. If you want to know why we don't see microbes before that, the radiation from the sun simply would not permit the existence of microbes on the surface of the Earth. Maybe deeper in the water, the oceans, but not on the surface of the Earth. And so it explains why we see microbial life beginning, but basically making the point that the moment that the sun's radiation permits the existence of microbes, we immediately see microbes. There's no time delay. Again, a profound challenge to any kind of naturalistic explanation for the existence of those microbes. They show up instantly, immediately, geologically instantly at least, when the sun's radiation permits their existence. If you want to know why the Creator waits so long to make animals, well, animals can't tolerate the radiation that microbes can tolerate. But the moment where the sun's flaring activity and X-ray radiation and particle radiation drops to a level that permits the existence of animals, large animals, we immediately see these animals. Again, no time delay. They show up the moment that the sun's radiation permits their existence. And when do we show up? We show up when the sun's radiation dangers and flaring activity is at the lowest level of all. And we have to be at the lowest possible level in order for us to exist. Now, what I'm going to be sharing, and I think I'm past my time, so this is going to be next week. I'll finish up this series on the sun. And hey, the best is yet to come. Basically, there's something that's newly discovered by astrophysicists saying what makes the sun so special that permits the existence of life, because all other stars we see have a flaring activity level way above what the sun manifests. They all have X-ray and short wavelength radiation, ultraviolet radiation, that would eliminate the possibility of existence. They've now discovered how it is. It's not just what we see with the neutrinos. Something far more important happened in the history of the sun that explains why we can be on a planet that orbits this just right star, a star like no other. In fact, next week I'm going to show you our star, the sun, compared to the second best star we have found. And so enjoy your Thanksgiving dinner, and remember to thank God for this miraculously designed sun we have into orbit. With that, let me open it up for questions. And as usual, we'll alternate between questions from those of you that are here in person and those that are participating online. But it looks like we have an online question.
We do. We have a couple already. Robert Gibson asked, the center of the sun is very hot. How does Doppler broadening affect the photons' peak as they travel to the surface of the sun?
Okay, now, by the way, Rob Gibson is one of our reasons to believe volunteers. He's been a volunteer apologist for many, many years, decades actually, very active in our chapters. And I think what he's asking, and I couldn't hear everything you were saying there, that we have a very high temperature in the core of the sun. How do we explain why it takes 100,000 years to get to the surface? Is that the question?
Well, he didn't put it that way. He said, how does Doppler...
Hey, please go to the microphone. I'm getting an echo effect.
Okay. He said, how does Doppler broadening... Oh, okay. Yeah, that's it. He asked, how does Doppler broadening affect the photons' peak as they travel to the surface of the sun?
Okay, a good answer to the Doppler effect as particles travel to the sun would be, I don't know. I mean, there's going to be some Doppler effect going on there, so Rob's onto something, but I don't know if any research papers have gone into that in detail. The main reason why it takes 100,000 years for a photon generated by our sun's nuclear furnace to get to the surface of the sun is the fact that that photon gets bounced around. It's the high temperature. The higher the temperature, the faster particles are moving. So there's a lot of movement going on at high temperatures. A lot of collision events are happening. Things are being diverted. And it's basically the photon being bounced around like this that explains why it takes so long to get to the surface. I'm sure there's a Doppler effect involved in all that. I don't know if anybody has actually determined how that might impact the travel time out to the sun, or for that matter, its energy level.
We could ask...
What we do is ask Rob to do a research study on this.
Yeah. Well, there you go.
All right. It's possible someone's written a paper on this. I have just not found anything. I did do a thorough research on the peer-reviewed literature on what's going on in the actual nuclear furnace. But as far as the Doppler effect of photons traveling out to the surface of the sun, I've not done that.
Okay.
If Rob wants to do it, that'd be great. He can report back to us.
All right. Rob, maybe if you want to modify your question a little with a little more information, send it in again. Valerie asked, excuse me, the in-house turn. Come on up.
Hi. We know that the geology tells us that the first life was started to develop about 450 million years ago. And you've associated that on your chart there, that'd be about 4 billion, at the time about 4 billion years. And you've associated that change with the change in change in the type of radiation reaching the Earth. And so my question is, is there any kind of consensus that change in radiation has led to the appearance of this life, or are there other theories that have been presented or that are advanced that would indicate why this life happened to appear at that time?
Okay, you'll see this in our book, Origins of Life, is that the main focus of scientists has been on the state of the Earth itself. How not until about 8.485 billion years ago did you have stable liquid water and you had rocks that remained solid. There were brief episodes before 3.8 billion years ago where you had liquid water and you had solid rocks, but it was brief. They refer to that period before 3.8 billion years ago in Earth's history as the Hadean Earth, which is a reference to hell, basically saying previous to, say, 3.8 billion years ago, Earth was hellishly hot. And that's because Earth had a very hot origin. I mean, you had the planet Theia colliding with the proto-Earth, which made the interior of the Earth blistering hot. And so the cooling from that event, that's also a time when Earth has a lot more uranium and thorium than it has today. And so the early history of the Earth is one where the Earth is hellishly hot. Now, they have found zircons, for example, that indicate there were a few regions on the Earth that were briefly cool enough to have solid rocks and liquid water. But they were brief and they were localized. Not until about 3.83, 3.84 billion years ago do you have stable liquid oceans and you have stable solid rocks. But the moment you got stable solid rocks and stable liquid water, you have these microbes. And a number of even atheists like Niels Eldredge have commented that that's one of the strangest things he sees in the history of the Earth. The very moment that conditions on Earth permit the existence of life, we immediately have life. There's no time delay like you'd expect from a naturalistic, atheistic perspective. It happens right away. What I'm indicating here is there are other factors that also explain the timing. The sun's radiation doesn't become sufficiently safe until about 3.83 billion years ago. And so there's probably multiple reasons for the timing. Now, if you do have a microbe that's, say, 15 feet below the surface of the ocean, that 15 feet of water would give it some protection from the solar radiation. However, it's not going to protect it from the hellish hot conditions of the early Earth. And so if the oceans are evaporating frequently because of the hot conditions, and by the way, there's another source of heat. When you get previous to 3.8 billion years ago, that's a time when planet Earth is being bombarded with big asteroids and comets. And when they hit, they heat things up. And so, but hey, there may be more reasons. I'm just suggesting another reason would be the solar radiation.
Well, okay, maybe possibly my question wasn't clear. I was really referring to the transition at half a billion years ago, where the blue line starts there. The blue. So at that point, that's when all of the when we have the appearance of animal species and their remains, and so that's the first appearance of animal species, or the remains at least, and you identified that event as occurring when the radiation got down to the level that that is a trigger for the growth of these of the animal species at that time. So my question is, are there other ideas or theories that would apply other than that radiation at that point?
The answer is yes, as probably a more significant factor. Where you see that separation between microbial life and animal life, that separation happens when the oxygen content in the Earth's atmosphere jumps from 2% up to 8%. At 2%, you don't have enough oxygen for animals with significant body sizes. At 8%, you do. That's the primary reason for why you don't see animals. And again, the very moment it hits 8%, you immediately have animals. What I'm suggesting, there's even more design involved in this. That moment when the oxygen jumps up to 8% is simultaneous with the moment when the solar radiation subsides to a point that permits the existence of animals with body sizes a meter across. So you've got a double design argument, and as I just pointed out, that double design argument also shows up at the beginning of microbial life. And I'm suggesting maybe we'll find other things that simultaneously line up at these transitions where we see life. But the fact that we see life appearing immediately, and we see God working things out, that when the solar radiation drops to a point where you can have animals, He also ensures the oxygen content goes up so we can get that. I would argue this is all evidence that God is aggressive in packing our planet with as much life as possible, as diverse as possible, for as long as possible, as we see Psalm 104 state. And so the fact that we see that the solar radiation drops to a point at the same time the oxygen level jumps up, to me, this is even stronger evidence for the supernatural handiwork of God. So thank you for pulling out of me a stronger apologetic argument. Appreciate that.
Valerie asked, is one of CERN's functions to open a portal to another dimensions, such as a spiritual realm?
Okay. CERN, that's referring to the Large Hadron Collider that exists in Switzerland and France. It's the world's largest particle accelerator. It's 17 miles long. And so you say, yeah, the longer the accelerator, the more energy you can produce. Because what these particle accelerators do, they're basically circles where they're accelerating particles in one direction around the circle and in the opposite direction around the circle, and they have them smash into one another to generate the energy densities that tells them what was going on in the early history of the universe. But it's also a place where they can explore particle physics at energy levels we can't observe without any other instrument. Of all the physics tools in our possession, this is the one where we see the highest energy density. And yes, there have been people speculating that the energy density that CERN is developing may be strong enough to produce a black hole that might give us a portal into another space-time realm, or a black hole that could suck the entire Earth into it, and we'd all be gone. As an astrophysicist, I can tell you, no need to panic. The reason why there's no need to panic is that we astronomers are observing sources in the universe where the energy density is tens of thousands of times greater than anything we see possible in the Large Hadron Collider. And we're seeing energy densities 10,000 times greater than what's possible for the CERN physicists to produce. Nothing weird happens. So we're not seeing any wormholes sucking everything that those energy densities being produced. So bottom line, it's one less thing for you to panic and worry about. I mean, pay attention to the COVID problem. That's something much more significant. Or maybe an asteroid striking the Earth. That has a much higher risk factor than physicists at CERN creating a black hole that causes all of us to disappear into a singularity. So, by the way, before they built CERN, they already knew that there was no risk from the high energy densities they were producing, because the astronomers told them, look, we're routinely observing sources in the universe where the energy densities are orders and orders of magnitude greater. Don't worry, go ahead and build it. Now, if we were to build a particle accelerator maybe 20 trillion miles long, then maybe we'd be having something to be concerned about. But I don't think that's going to be funded anytime soon. Go ahead.
Hey, Dr. Ross. Really glad to have you back. Recently, or about 5 years ago, Ted Koppel did a book on airburst, but it applies also to solar flares. So you described some of the negative effects. According to what I've heard in a recent documentary plus that book, it's 100 or 1,000 times worse than you described if there would be a significant event like that. So like the food supply, it's not just our refrigerator, it's a chain of refrigeration, its distribution. If we go more and more to electrical vehicles and electrical trains, it's just a major collapse. And before all this collapses, the moral situation that we're surrounded by more locally, we would have a criminal collapse. So it would be every man for himself. They estimate in these two books that possibly 90% of the population would be lost in a major event. And that would be in a matter of a few months. So it seems to me, now my question is, is it possible there may be events like this that are being predicted in the book of Revelations, in the seals and the vials that are opened?
Okay, good question. And yeah, it is worse than what I described, but not quite as bad as what Ted Koppel described in his book. Mainly because, that book was written a few years ago. And so there are some things that would make it a little less catastrophic. But keep in mind, when the 1859 solar flare hit, the population of the United States was about 40 million, maybe 35 million. The population now is 330 million. And so it's like we can sustain 330 million people because we have a power grid. And so what Ted Koppel was talking about, if you take out the power grid, our country cannot keep 330 million people alive. We need that sustainable source of electricity to keep all those people alive. Now, we could survive without power for a day. And people have done that. However, the problem with, say, an 1859 solar flare hitting today and knocking out the entire U.S. Power grid is it would take a long time to get it up and running. In the case of the knockout of the Quebec power grid, they were simply able to purchase the equipment to get it back up online. I think it took about a week before they got it up and running. And I write about this in Weathering Climate Change, that you need transformers to sustain the whole electric power grid. And the problem is we do not have the manufacturing capacity to replace all the knocked out transformers. And the one company that produces the most is in mainland China. And so it's like, I think the Chinese are going to want to make sure their power grid is up and running before our power grid is. And so I write about in Weathering Climate Change, knowing that a major flare is going to knock out, it means we're going to have to replace all the transformers, and we don't have a lot of them sitting in warehouses that we can just go and put up on one of these poles and replace the one that got knocked out, is that we would be wise, in addition to having our power grid surge protected, if we're not going to do that, let's at least have a few million of these transformers in storage somewhere. That's actually a little bit cheaper than putting surge protectors in on all the world's power grids. Just make sure you've got in storage enough transformers that when something like that happens, you can get the power grid up and running within a few days. The fact that we don't have enough of those transformers ready to be purchased means the power grid could be knocked out for up to 2 years. And that's what Ted Koppel was talking about. If we're without the power grid for a 2-year period, you're looking at hundreds of millions of people dying. And when hundreds of millions of people are dying, you can expect that people are not going to behave like they normally do. And so he's making the point that people who say have a backup to their electrical system, and I'll put up my hand. I, a few years ago, decided, hey, living in California, we might have, actually I figured out, we lose about a half hour of electricity every week because we live in the state of California. And because I'm doing podcasts all the time from my home, I put in a power backup system. So when a solar flare hits, I got electricity. Okay, now, all the people who don't have electricity, they're going to say, the Rosses have electricity. Let's just go to their home, we'll kill them, and we'll take over their system, and we'll have electricity. That's what Ted Koppel was talking about. The few people who have backup systems are probably going to be assaulted by those that don't have it. Now, one thing I've done in our neighborhood, we live in a cul-de-sac. I said, hey, if we ever have a brownout in California where you don't have electricity, I've got extension cords that are 100 feet long. And so as long as you promise not to turn your air conditioner on, I'll make sure all your refrigeration is okay. And you can get onto your computers, etc. So, because our system is set up where we can run one air conditioner, but not two. But if I want to help all the neighbors, the air conditioner uses the most power. So, but that's another way to deal with it. And by the way, California's better off than the rest of the country because a lot of people have backup systems. You can thank our electrical power grid and all of its problems for the fact that so many people have backup systems. So, and by the way, it's amazing. Usually it's Wednesdays where we have a dropout. I don't know what happens on Wednesday. Maybe that's when they decide to do repair or whatever. But it's like almost every Wednesday, we're out for 30 to 60 minutes. So you've probably experienced that. And I think they're realizing, hey, you can do without electricity for 30 or 60 minutes. And it's during the day when people are at work, so most people don't even notice it's happened. Well, we notice. But I'll tell you, these backup systems are amazing. We're only without electricity for a fraction of a second. It kicks in like that. And the moment the power grid's restored, it shuts off. It's totally automatic. So those are multiple ways we can deal with the threat of a major solar flare. But I'd argue the best thing to do is to protect the power grids. But if you're not going to do that, make sure you got lots of transformers in some kind of warehouse that you can go to when it happens. And it'd be good to have a few factories, even if you don't want to have it in storage, at least have some factories that are dormant. And the moment it happens, you run them up and you start churning out tens of thousands of transformers per day. And that way, within a week or two, you can restore the entire power grid. But yeah, I read Ted Koppel's book. He's right on the money. If we don't do something to protect ourselves from the inevitable, we're looking at a huge catastrophe. But there are ways to mitigate it. Yes.
Well, we're out of time, Hugh. We have two more questions from Robert and Craig, so I'll ask them if they could bring them back next week. We'll still be talking about the sun, so that would be a good time for them to bring it back.
Yeah, next week will be part 2 on the sun, and yes, bring your questions. If you think of questions between now and next week, feel free to bring them.
Okay.
But let me close our time in prayer.
Close in prayer, and then Marianne has something to say right after your prayer to the people in the class.
Okay, very good. Father in heaven, we thank you for this time that we've had together with you on this Sunday. Thank you for the people around the world that participate with us in this class. Thank you for the people that are here in person. And thank you for all of us that are here in North America, where we have the opportunity this coming Thursday to dedicate a day to thanking you. And Father, it's a wonderful time to get together with our relatives and friends. But I pray that not only on Thanksgiving Day, but every day, we would take time to express our gratefulness for you, for making such a wonderful planet on which to live, a one and only planet, a one and only star, a one and only galaxy. Lord, thank you for being so incredibly generous towards us. And thank you that you've even promised that we'll get to go to a place where there is no suffering for the rest of eternity and unbelievable joy and love. Thank you, Father, for doing that for us. In Jesus' name, amen.
There's this big bouquet of flowers on the snack table, and those flowers came